If n were any two finite sets, then n of A union B is equal to n of A plus n of B minus n of A intersection B. Now what is the formula? As usual, n of C union T is equal to n of C plus n of T minus n of C intersection T. 1, 3, 5, 7, 9. So 2, 4, 6, 8 and 10 comes under the complement of A. Hello dear students, welcome to this session of Mathematical and Statistical Computing class. I am Mr. Niranjan, Faculty Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding the definition of a set and types of sets. So today in this set theory, I am going to discuss regarding few more types of sets and Venn diagrams and application of sets. Very important concept is applications of sets. Now, let us discuss regarding the complement of a set. The complement of a set. The complement of a set is represented or denoted as A dash. A dash is called the complement of A, or sometimes we may also represent this as AC. AC is the complement of set. Suppose if U is an universal set and A is a subset of U, then the complement of A is denoted as A dash is equal to U minus A. A dash is equal to U minus A. All the elements of U other than A is called the A dash. That is called the complement. Suppose if B is the subset of U, if U is a universal set, B is a subset of U, then the complement of this is B dash or BC is equal to U minus B. That means all the elements of U other than B is called the complement of B, right? So the complement, that means let U be the universal set which consists of all prime numbers and A be the subset of U. Let us take for example, let U is the universal set which consists of all the prime numbers and A be the subset of U, which consists of all those prime numbers that are not divisors of 42. So this is also an example for a complement. Now, thus A is equal to X such that X belongs to U and X is not a divisor of 42. Now let us move on to the definition. What is the definition? Let U be the universal set and A is a subset of U, then the complement of A is a set of all elements of U which are not the elements of A, and it is denoted as A dash and given by A dash is equal to U minus A. That is, U is the universal set and A is a subset of U, then the complement of A is A dash is a set of all elements of U which are not the elements of A. Other than A, all the elements of U are called as A dash and given by A dash is equal to U minus A. Symbolically, we are going to represent it as A dash or AC. That is, A dash is denoted as the complement of A with respect to U. Therefore, A dash is equal to X such that X belongs to U and X does not belong to A. And obviously, we are going to represent it as A dash is equal to U minus A. Now, let us take an example. Let U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and A is equal to 1, 3, 5, 7, 9. Find A dash. So, here A dash is nothing but U minus A. The elements which are in U but not in A. In A we have 1, so 2 is not, 3 is also included, 4 is not included, 5 is there, 6 we can take, 7 is there and 8, 9 is there, then 10 is not there. Okay, 2, 4, 6, 8, 10. This is A dash, the complement of A. So all the elements other than 1, 3, 5, 7, 9. So other than 1, 3, 5, 7, 9 is 1, 3, 5, 7, 9. So 2, 4, 6, 8 and 10 comes under the complement of A. Now, how to represent this in a Venn diagram? The complement of A dash of a set can be represented in a Venn diagram. So this is the set, universal set, and the complement of A is A dash. This is all the elements other than A is called the A dash. So if this is A and other than A, all the elements are A dash. So A is the subset of the universal set U, then the complement of A dash is also the subset of U. A dash is also the subset of U. Now, Let us take one more example. Let u is equal to 1, 2, 3, 4, 5, 6. A is equal to 2, 3. B is equal to 3, 4, 5. Find A dash, B dash, A dash intersection B dash, A union B, and hence show that A union B whole dash is equal to A dash intersection B dash. De Morgan's law. This is very, very important. Now, just find out A dash. What is A dash? A dash is nothing but U minus A. All the elements which are in U but not in A. What we have in A? 2, 3. Other than 2, 3. 1, 2 is 2, 3 is gone. 4, 5, 6. This is A dash. What is B dash? B dash is nothing but U minus B. All the elements which are in U but not in B. So in B we have 3, 4, 5. So we can take 1, 2, 1, 2, 3, 4, 5 is gone. And what is left over is 6. So this is B dash. Okay. A dash, B dash. Now A dash intersection B dash. A dash intersection B dash. The intersection. So what is the common in this A dash and B dash? So 1, then 4 is not there, 6. 1, 6 is the intersection. The A dash intersection B dash. Then A union B. Find out A union B. What is A union B? Here A union B is nothing but the union of A and B. A contains 2, 3. B contains 3. Already we have written 4 and 5. Right. A union B. Now, what is to prove? To prove that A union B whole dash. Now, here let us represent this as equation number 1. A dash intersection B dash. Already we got represent it as 1. This is the right hand side of equation RHS. Now, find out LHS. Already we got A union B. A union B whole dash can be written as U minus A union B. So, all the elements which are in U but not in A union B. So, in U we have 1, whereas 2, 3, 4, 5 is already in U, that is 2, 3, 4, 5 we can leave. And what is the extra element is 6. So, let us represent this as equation number 2. So, A dash intersection B dash, that is from equation number 1, is equal to A union B whole dash. This is LHS. So, therefore, from 1 and 2 we can say that we can say that LHS is equal to RHS. Therefore, A union B whole dash is equal to A dash intersection B dash. That is the well-known law called as De Morgan's law. Now, let me take one more example for De Morgan's law. Now, this is very, very important. You may expect this for 6 marks in your final examination. Let U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. A 2, 4, 6, 8, B 2, 3, 5, 7. Prove that A union B whole dash is equal to A dash intersection B dash, and A intersection B whole dash is equal to A dash union B dash. Right. Now, first find out A union B. A union B. What is union of A and B? So, A contains 2. Again, in B we have 3, 4, 5, 6, 7 and 8. This is A union B. Now, write down the LHS of equation number 1. LHS is A union B whole dash is equal to U minus A union B. So, what is this equal to? This is equal to all the elements other than this A union B in U. So, in U we have 1, we do not have 1 in here, 2, 3, 4, 5, 6, 7 is there except 9. This is equation number 1. Right. Now, find out A dash. A dash is equal to U minus A. All the elements which are in U but not in A. In U we have 1 not in A, 2 is there, 3 is not there, 4 we have, 5 is not there, 6 we have, then 7, we have 8, 9 is not there. This is A dash. And B dash is nothing but U minus B. All the elements which are in U but not in B. Other than B is the B dash. So, other than B is 1, then 2 is there, 3 is also there, 4, 5 is there, 6, 7 is also included, 8 and 9. Then write down the RHS. RHS of this. RHS is A dash intersection B dash. So, what is A dash intersection B dash? So, the intersection of these two, A dash and B dash. So, what is the common element in these two? 1, then 3, 5, 7 and 9. So, these two are the common elements, 1, 9. What do you say from these two? Therefore, from 1 and 2, LHS is equal to RHS. 1 9, that is A union B whole dash, A union B whole dash is equal to A dash intersection B dash, A dash intersection B dash. So the first one is proved, right? Now move on to the second part. Whereas for the second one, so A, already we have A dash intersection B dash. So what is A intersection B? First find out A intersection B. So the common in these two, A and B, what is the common? 2. Then 4 is not there, 6, nothing is there, only one element, that is 2 is common. Now what is A intersection B whole dash? This is U minus this element, that's nothing but other than 2. 1, 3, 4, 5, 6, 7, 8 and 9. Let us represent this as equation number 1. Now right hand side, A dash union B dash, A dash union B dash. So what is A dash? This is A dash and B dash. Union of this is 1, we don't have 2, then 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Right. Now this is equation number 2. Now what do you say from these two? 1 and 2, LHS is equal to RHS. So therefore from 1 and 2, LHS is equal to RHS. 1, 3, 4. So therefore what is the conclusion? The conclusion is A intersection B whole dash is equal to A dash union B dash. This is the second part. That's it. Okay. This is how we are going to verify De Morgan's law. Very important concept for the point of examination. Hope you followed. Now let us move on to the next concept, that is practical problems on a union and intersection of two sets. This is very important concept. You may expect one 5 marks or 6 marks question from this. In general, if A and B are two finite sets, then n of A union B, number of elements in A union B is equal to n of A plus n of B minus n of A intersection B. If A and B are any finite set, two finite sets, if A and B are any two finite sets, then n of A union B is equal to n of A plus n of B minus n of A intersection B. Suppose if A and B are finite sets and A intersection B is a null set. If intersection is a null set, A and B are disjoint sets, then n of A union B is equal to n of A plus n of B, because this n of A intersection is a null set, it becomes 0. So n of A union B is equal to n of A plus n of B. For disjoint sets, n of A union B is equal to n of A plus n of B. For a two finite set, n of A union B is equal to n of A plus n of B minus n of A intersection B. Now, let us move on to a simple example. Now, if x and y are two sets such that x union y has 50 elements, number of elements in x union y is equal to 50, and x has 28 elements, number of elements in x is 28, and y has 32 elements, number of elements in y is 32. How many elements does x intersection y have? So we have the formula n of x intersection y is equal to n of x plus n of y minus n of x union y. So n of x intersection y is equal to n of x, number of elements in x is 28, in y it is 32, minus number of elements in n of x union y is 50. 32 plus 28 is 60, minus 50, that's equal to 10. Therefore, the number of elements in x intersection y is equal to 10. 10 elements are common. That's it. So just write down what is the given values. Given n of x union y is 50, n of x is 28, n of y is 32. What is to find is n of x intersection y. N of x intersection y is the question mark. The formula is n of x intersection y is n of x plus n of y minus n of x union y. 28 plus 32 minus 50, that's equal to 10. Right. Now move on to the similar type problem. In a class, there are 20 teachers who teach mathematics or physics. Of these, 12 teach mathematics and 4 teach both physics and mathematics. How many teach physics? This is also an important concept. Okay. Now, in a school, there are 20 teachers who teach mathematics or physics means union. So, n of m union maths union physics is equal to 20. Then, Of these, 12 teach mathematics and 4 teach both physics and mathematics. So, how many will teach mathematics? So, number of n of m is equal to, so 12 teach mathematics. Then 4 teach both maths and physics. Maths and physics means that is nothing but intersection. So n of m intersection p is 4. Then what is to find how many teach physics only? Number of teachers who teaches physics is the question mark. So what is the formula? As usual, n of m union p is equal to n of m plus n of p minus n of maths intersection physics. Now m union p is 20 is equal to n of maths is 12, n of p we don't know, minus intersection is 4. So that is 20 is equal to 12 minus 4. 12 minus 4 is 8 plus n of p. Therefore, n of p is equal to 20 minus 8 is equal to 12. So the number of teachers who teach physics is 12. 12 teachers will teach physics. That's it. Okay. Right. See, very simple. Number of teachers who teach maths or physics is 20. Only maths is 12. So only physics is to be determined. Both is 4. Just subtract, you will get the answer. Move on to the next problem. In a survey, 400 students in a school. So that is what is given. N of u is equal to 400. In a school, 100 were listed as taking apple juice. Number of students who take apple juice is 100. N of A is 100. 150 as taking orange juice. Call it as B. Number of students who take orange is 150. Call it as N of B. So, in a survey, 400 students in a school, N of U is equal to 400. 100 were listed as taking apple juice. Number of students who take apple as A is 100. N of A is 100. 150 taking orange juice. That is N of B is equal to 150. And 75 are listed as taking both apple as well as orange juice. That is N of A intersection B is equal to 75. Then find how many students were taking neither apple nor orange. So N of A union B is to be determined. That's it. Okay. Now what is the formula? So the formula is N of A union B is equal to N of A plus N of B minus N of A intersection B. N of A, number of A is 100 plus N of B is 150 minus N of A intersection B is 75. So what is this equal to? 150 minus 75 is 75. This is equal to 175. Okay. Now, what is to find here? How many students were taking neither apple juice nor orange juices? So therefore, the required answer is equal to this 400 N of U minus N of A union B. That is nothing but 400 minus 175. That's equal to 225. So the number of students were taking neither apple juice nor orange juice is 225. Right. Now, move on to the next problem. In a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis? Right. Right. So, in a group of 65 people, 40 like cricket. Number of students who like cricket is 40. Then 10 like both cricket and tennis. Cricket intersection tennis is how many students? 10. And 65 people means N of C union T is equal to 65. Then how many like tennis only? N of T is to be determined. This is the question mark. Now what is the formula? As usual, N of C union T is equal to N of C plus N of T minus N of C intersection T. So N of C union T is 65 is equal to number of who plays cricket is 40 and T we don't know, tennis, and intersection. What is intersection? 10. So this is 65 is equal to N of T plus 40 minus 10 is 30. Subtract this. 65 minus 30 is equal to n of t. What is 65 minus 30? That's 35. Therefore, number of students who play tennis is 35. So 35 students will play tennis. That's it. So how many like tennis means 35 students will like tennis. So very simple. N of C is 40. N of C intersection T is 10. What is required to find is N of T. C union T is given. Just 65 is equal to 40 plus N of T minus 10. 40 minus 10 is 30. 65 minus 30 is 35 is the number of students or number of people who likes tennis. That's it. This is how we are going to solve this type of problem. So these are one of the application of sets, practical applications of sets. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.